100 Newton. Weighs 100 Newton. The vertical wall is smooth, so this one is smooth. No friction, there is no friction. The floor is rough and its coefficient is given. The floor is rough and the mu(SN) is 0.8. Find the minimum force P, that's the force P, to move the ladder. Movement is either slip or tip. Very interesting, and common sense is needed. Very interesting. So simple words, you draw the 3-point diagram and then we will have a look. So let's first draw the 3-point diagram of this. It's very easy what you're getting here. You got an active force which is here. You got the weight acting downward which is here. You've got the reaction force from the wall which is here. And this is the point where you got 2-point reaction. This is the friction and this is the reaction because of the weight. So you got two forces there. So 3-point diagram of this is equal to this. Is that clear?
Yes, sir.
Yes, sir.
Okay, good. Okay, so let us assume it's going to tip. Tip means the ladder will fall like this. Am I right?
Yes, sir.
Because it's not going to slip. No slip, we are assuming. So it means the ladder will rotate and tip. So at the verge of tipping, what you think will be the value of NB?
Sir, 0.
0, yes, it's at the verge of tip. So the value of NB will be 0.
Because it will lose contact
Okay.
with the vertical surface.
Is that clear to everyone?
Yes, sir.
Yes, sir.
No, sir.
Okay, so assuming NB equals to 0, can you find the value of P for me? And once you find the value of P, what you have assumed is going to tip. It is going to tip. This you have assumed. If you assumed it's going to tip, then you have to find your F, which should be less than mu(SN). After finding your P, you have to verify your assumption was right or wrong. For that, you need to find the value of FA, and this FA value should be less than mu(SN). If it's less than mu(SN), it means it's not going to slip. Is that clear? Less than or equal to, let me put it there. Is that clear?
Yes, sir.
Okay, do this for me. Find P for me, and then also find FA value for me. I want you to find P and FA for me. NB equals 0.
So what was the coefficient of friction? It's not given in the diagram. Okay, sorry. Sir, so P and FA are both same. They are coming out with 75, and the maximum friction calculated by mu(SN) is 80.
Okay, just a second. Okay, so let us see what the values we are getting. This is what you're getting. So you're getting FA is 70. So what is the value of F mu SN?
It's 80, like
89?
0.89.
80,
No,
sir.
80 newtons.
Okay, hold on. You found your P. Now we want to verify the assumption was right or wrong. Okay. So mu SN tells us it's 90, which is not equal to or is less than 75. So means our assumption of tipping is correct. Is that clear?
Yes, sir.
Is that clear to everyone?
Sir, how
Yes, sir.
n of b is equal to 0? NB is equal
How
to
NB is equal to 0?
Yes, sir.
Okay. Let's go back. Let's go to this one. Okay, look at this scenario. Forget this. Look at the real picture. At the moment of tipping, at the moment is just about to tip. What do you think? What would be the position here? What do you think? What's happening at this end? At the moment of tip, this will be in contact with the floor all the time. Am I right?
Yes, sir.
Okay. So what do you think at the knife edge of movement of the ladder in this direction? What do you think? What's happening here?
It will be slightly touching the wall if it is at a tip
Slightly.
of.
Okay. Let us say it's a feather touch. You agree with me?
Yes.
So would you consider a feather touch equal to 0 force?
Yes, sir. Okay.
Will you consider it equal to 0 force?
Yes, sir.
So therefore NB is 0. Is that clear now?
Yes, sir. It is clear. Thank you.
Okay. Students, can I move on?
Excuse me, sir.
Yeah.
Excuse me, sir.
Yes.
Sir, what if we started this problem by assuming that the ladder was about to slide? Then what? Then wouldn't we be able to solve the problem?
You're assuming you're saying it's going to slip.
I'm saying that if I
Okay.
I started this problem by assuming.
I understand. Basically, what you're saying, if you assume that it's going to slip, and then you start solving your problem. Am I right?
Yes.
Is that what you're
Yes, sir.
saying?
Yes, sir. Right.
Remember, common sense. You will struggle. Some scenarios are where you have to use a bit common sense. And that's one of the problems with the engineers. They always think they've got the formula and just apply it and you'll get the result out. No, sometimes there's no need to apply an equation. Just use common sense. Is that clear?
Yes, sir.
Remember, gentlemen, remember, look. Why it says here, vertical, smooth, no friction. There is a reason. Okay. You can start by solving, yes, but you will struggle, you will not be able to solve it. So therefore, I always say sometimes it's common sense. It's very clear. If it's going to tip, the value here is 0. And this kind of scenario will come in your problems. Okay? Just use your common sense. You will easily figure it out. Because remember, look, if you assuming this is going to slide, I take your point now, okay? You want to consider this is going to slide, okay? So you've got a friction force. So it means that you will have a friction force here also, but it says it's a smooth one. Therefore, you will not be able to calculate. Give it a try, okay?